right, let's start today's lesson talking about something you already know. So if I gave you this particular function right here, and you can see that it's squared, one option that you could do before you even take the derivative is just go ahead and FOIL that, which becomes 9x to the fourth plus 6x squared plus 1. And then doing the derivative of that is just the power rule, right? One of the easier rules, 36x to the third plus 12x. Okay, so again, easy enough. And I do want you to factor that though. So that would become what, 3x squared plus 1. All right, now again, that's not new. But the question becomes, what if that number right there hadn't been a square? What if it had been like a 3 or a 4 or, like, heaven forbid, like a 5, right? You would not want to multiply that times itself 5 times before having to do the derivative. So that's why we have something called the chain rule and why I gave you M&Ms. Okay, so you're going to want to work your way out from the inside. Okay, so if you're looking in this rounded rectangle, this right here is like the inside function. So for that example that we just did up top up here, I would say, oh, well, that would make g of x 3x squared plus 1. And then the other function is just g of x squared. So the rule looks like this. You're going to work your way out from the inside, which is g prime of x. That's the derivative of the inside. It's like what I would consider the derivative of the peanut on your M&M, right? And then you would do the derivative of the original function, which would be f prime of g of x. So this, let me change this just for a sec. Hold on. This would be like doing the derivative of the peanut. This is the derivative of the M&M. All right. Now, let's do this as if we're using the chain rule. So I'm going to rewrite it. We'll see if this makes sense. F of x is then going to be g of x squared. And our g of x is 3x squared plus 1. So when I'm doing the derivative, I'm going to do the derivative of whatever g of x is, and then 2 times the derivative of g of x. That's just using the power rule that you're used to. So g prime of x, if this is g of x, is 6x. Then I've got this 2, and then the original function, which is 3x squared plus 1. Then I'm hoping you see, when I multiply these two together, that I get 12x times 3x squared plus 1, which was the original answer that I got up here. Okay, it's just using the chain rule. Okay, now this notation down here is called Leibniz notation. You've seen it before, but I want you to see this exact same problem done just a different way. All right, so, and this may pop up, it may not on the AP exam, but if dy dx is equal to dy du times du dx, I want you to see this, again, the exact same problem done this way. So let me show you. I'm going to call y f of x. In other words, I'm calling it u squared. And the u is our original g of x, which is 3x squared plus 1. Now, if I did the derivative of u with respect to x, I just get 6x. And over here, if I did the derivative of y with respect to x, and this is weird because there is no x in here, you end up with 2u du dx. And the only reason I'm showing this to you, to be brutally honest, is that this right here is a sneak peek at something called implicit differentiation. We're going to cover that this chapter. So I just wanted you to kind of see it at least right now. Once. If you get it now, that's fine. If not, please don't worry about it. Okay, so now when I start substituting back in, dy dx is going to be 2 times u, which is up here, 3x squared plus 1, times du dx, which is 6x. And if I clean this up a little, I still get 12x times 3x squared plus 1. Okay, let's move to the second page and see if we can do these. Now, you'll hear me say this a lot. I'm going to start with the peanut. I'm going to start on the inside and work my way out. So on A, let me just focus in on A here. This right here is the peanut. Okay, and the whole thing is the M&M. Right? So when I go to do this derivative, I'm going to do the derivative of the peanut first. So the derivative of just the peanut, right? Just the stuff inside is 2. And then the derivative of the whole thing. Let me switch colors so you can see this is different. That means I'm taking the 3, I'm putting it out in front of the whole thing. I keep the stuff that's in the parentheses and I subtract 1 from my exponent. And when I clean that up, the entire derivative here is 6 times 2x plus 5 squared. Okay, let's try another one. Here comes part B. Okay, so this inside right here is the peanut. This whole thing is the M&M. And when I go to do the derivative, I'm going to start at the inside and work my way out, just like you would before when you did problems that involve parentheses. So the derivative of the peanut is -7. Then the derivative of the M&M takes that 5, puts it out in front. The stuff that's in the parentheses remains the same, and I subtract 1 from that exponent. And when I clean that up, I have -35 times 10 minus 7x to the 4th. Okay, let's keep going. Okay, here we go. So this one has a constant out in front of this function. Constant. This inside the parentheses is my peanut. Okay, and then this entire thing is the M&M. Okay, so here we go. Doing the derivative starting with the peanut. The derivative of the peanut is -1. Okay, doing the derivative of the M&M, I take that 4 and I multiply it by the constant that's out in front. That's 12. I keep the stuff that's in the parentheses, and then I subtract 1 from that exponent. So when I clean that up, I have -12 times 1 minus x cubed. All right, let's keep going for D. Okay, so now these are getting just a little bit harder. Okay, just a little harder, not a lot. Okay, don't freak out or anything. So here I have a peanut, and here I have an M&M. Here, this is just a single term, right? I can take the derivative of that fairly easily, and this is a constant. The derivative of the constant is just 0. Okay, so sometimes you may have to do the chain rule along with other stuff. So I'm going to start with this peanut M&M situation. The derivative of the peanut is 3. The derivative of the M&M, so I take 2 times the 1/2, which equals 1. I keep my parentheses and subtract 1 from that exponent. Okay, now I'm going to move on to this term. The derivative of 5x is just 5. And finally, I move down here to this constant. The derivative of that is 0. So let me just clean this up. This becomes 3 times 3x minus 2 plus 5. That is not in factored form, so I'm going to distribute, which gives me 9x minus 6 plus 5. And then combining like terms, I get 9x minus 1. All right. Now, down here, and you've seen things like this before, right? Where you have to do things based on the table. Okay. In fact, you just saw this on your test last week. So I'm going to use one color for the top half of this, right? I'll do part 1 in blue. I'll do part 2 in a different color. All right. So if I have this as my, what h is, first let's find what the derivative is of the first h function. I'm going to work my way in from the innermost parentheses. So the derivative of just x, that's 1. The derivative of f of x is f prime of x. And then the derivative of the entire thing is 2 times f of x raised to the first. All right, now they want me to evaluate this at 3. So let's see, f prime of 3, I'm looking at my table here, making sure I get the right number, is 1. Then I've got this 2. And f of 3 is 3. This whole thing equals 6. Okay, now let me switch colors. I'll do the second one in pink. Okay, so in pink, let's do the derivative of h sub 2. Starting inside the parentheses, I have a derivative of just 1. Then the derivative of g of x is g prime of x. And then the derivative of the entire M&M is f prime of g of x. And they want me to evaluate this one at 4. So let's see, I've got 1, and then g prime of 4 is negative 2. And then f prime of, oh, okay, hold on. G of 4 is 2. I may have to write one more line. 1 times negative 2. F prime of 2 is 1, which then equals negative 2. All right. Now, my suggestion, okay, is pause the video and try this next problem on your own. And then watch me do it. I'm going to do the top one in green. Okay, top one in green. So let's find the derivative of h1. So derivative of f of x is f prime of x. That's the peanut. Times the derivative of the M&M, so that's 2 times f of x. And now I can go ahead and put 4 in there. F prime of 4 is 2. Then I bring down this middle 2, and f of 4 is 3. That equals 12. Okay, let's do the second one in purple. All right, so let's take the derivative of h sub 2. Starting with the peanut, the derivative of the peanut is g prime of x. Then the derivative of this function is going to be f prime of g of x. And now I should be able to plug in 3. G prime of 3 is 0. Oh, I'm done. 0 times, it doesn't matter what this ends up being. 0 times anything equals 0. All right, there's your first lesson on chain rule.